Welcome to our this Biosensor lecture series. So in this video we are going to see the cell-powered biosensor based on the technology of using nano generator. So already we discussed how the nano generator device can be utilized for the cell-powered immunosensor and cell-powered DNA hybridization detection based on the change in the voltage. So the mechanism of nano generator for producing electricity is a very simple phenomena. So it is also very old, very conventional phenomena. Using this phenomenon, currently we are using the next generation biosensor based on this electricity produced by the nano generator. So it involves the piezoelectric material and triboelectric material and pyroelectric nano generator. So it is a simple things. So this is the basic mechanism for in between the two electrode we can incorporate the nano generator material either piezoelectric or triboelectric or pyroelectric material. When applying the mechanical process, it produces some decent voltage. Based on the output voltage, we are utilizing the changes phenomena in the bioreceptor or biorecognition layer. Indirectly, it is correlated to the how the molecules, biomolecules interact with the bioreceptor and how the voltage output significantly affect, which can be easily correlated to the for the detection of various compounds. It is particularly used for the biological small biomolecule detection and environmental pollutant detection and food related additive and adulterant detection can be used in this direction. Next we are going to see the cell power biosensor based on this nano generator devices. For example, here we are between the two conducting substrate. We have developed so in this work they have developed a PVDF and PTO material. So both are is a piezoelectric material. So it can be when applying a physical when applying a mechanical force, it can produce some voltage. So based on the change in voltage, we can easily assume that the sensor can able to detect the some particular molecule. So for example, here they have developed a glucose sensor using these nano generator devices, which has been published in the Journal of Sensor and Activation in the year of 2016. So here this is the fabricated devices. They used PVDF PTO composite material as a voltage generating material as a nano generator device between the two conducting electrode. So this is the morphology of the fabricated material. It is look like a spherical morphology. Here morphology role is not much important. But the characteristic of the material polymer and inorganic material is major role. It is directly depends upon the outage voltage. So after fabricating, it is a simple, very thin device. It can be flexible. So here the fabricated device has been applied for the detection of glucose. So it is known that conventional glucose detection by electrochemical method, it is involved multiple steps. So for example, the glucose can be detected by either two methods. One is enzymatic approach and non-enzymatic approach. In this enzymatic approach, usually what they will do, they will use a enzyme which is called a glucose oxidase, which has been immobilized over the transducer surface or electrode some conducting substrate in presence of some nanomaterial like conducting polymer or metal oxide or carbon material has been immobilized with the glucose oxidase. So the glucose oxidase enzyme is a specific reaction which is specifically interact with the glucose. Then it converted into the gluconic acid. Meantime, while converting the glucose to gluconic acid, it will produce hydrogen peroxide. The hydrogen peroxide has we can easily monitor or we can easily detect by electrochemical approach. In the conventional things, first initially the electrode modified with the enzyme in presence of various nanomaterial, followed by which is called working electrode. and then we have to in screen printing. If you take a screen printing electrode, the working electrode comprise of glucose oxidase enzyme plus nanomaterial or some nanoparticle like platinum, gold, anything we can utilize, which is for the nanoparticle, the nanomaterial main role to enhance the signal, because the producing glucose into gluconic acid, the hydrogen peroxide level is low. In order to enhance the quantity of hydrogen peroxide, always that interaction of glucose and the transitive surface can be efficiently improved by the nanomaterial with the enzyme modified electrode. This which is called a working electrode. Along with this working electrode, another two types of electrode has been fabricated. One is called reference electrode. Usually silver chloride used as a reference electrode because it is a more durable or more without any disturbance. It can be work in a neutral condition, because in glucose sensor mostly we are applying in the neutral atmosphere. Hence, this glucose sensor, because we used in the blood, our sample, so it has a neutral pH. Psychological, we can call this a psychological pH. So what will happen when interacting with the glucose? So the reference electrode, silver electrode is more suitable for this glucose detection. And plus, another third electrode is here counter electrode, or final electrode, which is it is used for the completion. So the third electrode main purpose is a conducting. It should be a conducting and also does not involve in the electrochemical reaction. So usually here we can use platinum wire or platinum coated film or a graphite rod, like that. Some conducting substrate we can use it as a counter electrode. So this is the conventional electrode setup, followed by we can add, when adding the glucose enzymatic reaction will happen and hydrogen peroxide produced, which was monitored by the some electrochemical technique from cyclic voltammetry or amperometric or differential pulse voltammetry or potentiometric. So these are involving various steps. For example, here just developing a nano generator, it is a very thin film and a flexible substrate. After fabricating, when adding glucose, it converts the some reaction without applying any potential, because itself it has generated some potential when applying a physical pressure or a mechanical force. The developing voltage through applying the mechanical force is sufficient to oxidize this reaction. So without any external applying a voltage or current. Whereas in the conventional electrode, we have to apply a particular voltage or current to drive the oxidation reaction with the enzyme. Whereas here we no need to add any external electrochemical workstation or potentioamperometry meter. Directly, the device itself can able to oxidize a glucose into gluconic acid. See here, this is the device, fabricated device. When device that new or the bare piezoelectric device can produce a output around a 2 volt plus 2 to minus 2 volt when applying a mechanical force. So further, when adding the glucose, what will happen? The glucose reaction, oxidation reaction has occurred. So here main advantage, we are not using any enzyme reaction. So the electrode can be reusable. This is the main advantage when fabricating a cell-powered glucose sensor. See here in this graph, when adding the glucose 50 micromole, 100 micromole, 200 micromole, 300 micromole, 400 micromole, like that, we are increasing the concentration of glucose. So we can visibly see clearly when increasing the glucose concentration, the output voltage significantly decrease from the nano generator. Whereas in the initial state, without adding any glucose, it gives me a maximum voltage of plus 2 to minus 2 voltage. Whereas when adding the 50 micromole of glucose, the mild decrease in the voltage we can observe. Further, when increasing the concentration of glucose, the gradually the output voltage of the nano generator decreasing. So it indicates that the fabricated nano generator device has effectively utilized for the glucose detection. So this output voltage directly correlate to the concentration of glucose. See here, when the concentration is at the zero, it provide a 1.8 volt. When increasing the concentration, slowly the potential gradually decreasing. From 1.8 to we can observe around 0.2 volt at the concentration of 1 millivolt. So we can easily correlate between the concentration and the voltage. So suppose if the device producing this much voltage, we can simply say this much concentration glucose has been present in our sample. So this is the main aim of the cell-powered glucose sensor. So this is a new trend. So here main advantage, conventional enzymatic glucose sensor, we are using a enzyme. It is a high cost. Enzyme generally it is a high cost. This is the main disadvantage. Further, the enzymatic electrode we cannot reuse. It is generally use and throw electrode. Once if you utilize the enzyme based electrode, we cannot reuse. We can use each measurement new electrode. Whereas here it is a non-enzymatic approach. Here the electrode even after the different addition of glucose, we can simply wash in the presence of phosphate fiber solution. Then again we can repeat the same experiment. So the reproducibility of the non-generator voltage also we can get nearly similar voltage. So compared to enzymatic method, this nano-generator cell-powered glucose sensor as highly reproducible and reusable. This is a more advantage compared to the conventional what we are using in the glucometer. So another conventional is a non-enzymatic method. So this is also the main drawback. It involves different steps for the fabricating nanomaterial and electrode. It comprising 3 electrode. And mostly the non-enzymatic electrode we are using in alkaline condition, because the alkaline condition only the non-enzymatic electrode can effectively oxidize the glucose into gluconic acid. This reaction will happen. So hence most of the studies the alkaline usually 0.1 mole sodium hydroxide is more favorable for the glucose oxide. This concentration broadly used for the non-enzymatic approach. So based on nanomaterial based non-enzymatic approach involve multiple steps. Here also the reproducibility and repeatability is good, but however when continuously using the performance slowly decrease. Whereas in this nano generator device, it has a highly attractive property. Even several experiment does not affect the output voltage. So this is the new direction for the fabrication of cell-powered glucose sensor based on nano generator. This is one example for the glucose. Similar way, the different kind of compounds or analyte we can able to detect based on these cell-powered sensors. So here main advantage no enzyme, the fabrication is very simple and does not require any complicated or expensive instrumentation to monitor the output. It is the total size of the device is 1 into 1 centimeter. So it is a we can fabricate this device, a handheld device. Similarly, the same approach we can apply for also other analyte molecule like ascorbic acid, dopamine, uric acid, L-dopa, and there are different, for example, different vitamin, and also we can use for environmental sample. Still, there are extensive research now under process, but the main drawback of the cell-powered glucose sensor, the mechanism still not we cannot clearly explain by oxidation of this analyte molecule, because the generating voltage is some particular voltage, but clearly we cannot conclude how this oxidation is happening. So similarly, the voltage output voltage, similarly the analyte oxidation voltage is different for based on the analyte. Glucose it will oxidize one particular voltage, whereas another molecule, for example, if we take ascorbic acid, it require a high potential, whereas if we take some nitrate, it is one of the water pollutant. The nitrate compound easily dissolved in water. It comes from the agricultural activity. It is highly toxic compound. So the detection nitrate is a major role in the analytical chemistry. So here nitrate usually it will be oxidized more than 1.1 volt. So the nanogenerator device and the output, we cannot claim it can be obey for the same nanogenerator device can be obey for all the sensor. So based on the tuning the voltage, we can the analyte detection and analyte choosing parameters also will significantly affect. So hence we need a in-depth research on this topic. So next, similarly, the cell-powered biosensor. So here they fabricated PT nanoparticle and aerogel matrix and then PET substrate. They used polyethylene terephthalate substrate, and then the nanomaterial has been degraded over the substrate, and then this nano-generated device has been fabricated over with the covered PDMS polymer. PDMS, it is also can produce electricity. It is one of the well-known material in the, we can be broadly used for the nano-generator device fabrication because it is a highly flexible characteristic of the PDMS polymer, and also more advantage, it is a transparency characteristic. So in this work they have used this nano-generator device and successfully applied for the system sensor. See here, this is the nano generator signal output before applying any analyte molecule like cysteine molecule. So we can see the voltage we can apply. For example, this is a nano generator sensor. When adding the cysteine molecule, the signal can see the clear difference. This is a very low concentration, that's why we cannot observe a very clear signal. So here, for example, this is the different concentration and then voltage response. This is the control as fabricated nanogenerated output voltage. When adding the cysteine in the concentration of different concentration significantly affect the voltage of the output of the nanogenerator. So based on this output, we can easily correlate the cysteine biosensor. Similarly, there are n type of molecule currently they are investigating by changing the nanogenerator composite material and electrode fabrication. Based on this fabrication device, based on using the type of nanomaterial in the nanogenerator can be tunable for the different type of analyte sensor. So this is a important topic. Currently, there are many research ongoing for developing a different type of sensor in various applications like biomedical, environmental detection, and pollutant detection, food adulterant and additive detections. So another important thing, this is not related to nanogenerator. However, another way of biosensor compared to the conventional biosensor, nanogenerator has great potential because it is make as a self-powered system, does not require any external voltage source. So another in this direction, paper-based biosensor, it is also important topic because the main advantage of this paper-based sensor, it is affordable, inexpensive, abundant, sensitive, and specific, user friendly. Within a few minutes or less than the response is developed. So further, this paper based sensor, no need of any special equipment. Just paper can act as a equipment. We can the output we can see simply, we can see our naked eye. Finally, the deliverable to end user, they are quite stable and wide range of temperature and time. So the paper is very low cost. Even we can use for some parchment paper also. So this is the simple protocol how we can utilize for the paper based biosensor. Initially, the bath can be created using the some microplastic device is by using a wax coating. So this wax coating, it acts as a hydrophobic barrier. So when and also this without wax coating, which act as a microfluidic absorber. So when you adding some analyte, what will happen? It will diffuse and penetrate into the all part of this paper. Whereas this beyond this liquid or this electrolyte cannot move because this is hydrophobic region from wax coating. So this is the wax spirit coating. So what will happen? After that, when reaching the solution here, then we cannot the solution cannot move here because it is restricted by the wax coating. So what will happen? Initially when adding the some drop, it will diffuse in the all direction. See here. So here before adding the solution, we can pre-modified some enzymatic reaction or some aptamer based things or some nanomaterial. So what will happen when adding the analyte molecule, it will diffuse into the all direction. So in particularly interact with this already pre-modified electrode, what will happen? If the reaction happen, it will produce some color. Suppose if it is not happen, the color does not change. This is the beauty of this paper-based sensor. So we can detect our naked eye like yes or no type. Similarly, it is not only say this paper-based sensor yes or no, and also we can accurately quantify the concentration of this particular analyte by further establishing the image device digitalization, the result, and transmit them to an expert. Finally, the output can be easily monitored and analyze how much concentration exists in the analyte. See here, there are four spots we can see. Here, each part we can attach different kind of biomolecule to detect the four type of analyte. For example, here the mixture of two analyte exist to investigate here. So here total 10 analyte we are mixing. So only two analyte can interact here. So when the analyte molecule when diffusing here, so here does not interaction. So only here two interaction because here the pre-modified depends upon the particular analyte. So based on this paper based we can detect multiple detection, not only a single analyte. Whereas in the biogen the nanogenerator device we can at present we can able to detect only single analyte. Whereas this paper based biosensor we can detect a multiple analyte. In this case we can detect a four type of analyte. So this is the main advantage for this paper based technology because it is a very inexpensive. We can fabricate for fabricating this electrode does not require any highly sophisticated instruments. Simple wax coating or wax printing we can apply. Currently there are different technology for printing this paper based sensor are existing for fabricating for developing different sensor. So this microfluidic paper-based sensor analytical device sensor has been significantly developed by that Professor Daniel Sitirio, Kyoto University, Japan. So he has extraordinary work done based on this microfluidic paper-based analytical device. He is also one of the chief editor in the Journal of Sensor and Actuators. So he has developed a different type of approach. Both it can be detected by naked eye and also colorimetric approach, and also they have developed a electrochemical approach. So different approach has been used in paper-based analytical survey, which is called a micropad. So compared to the conventional method and also non-generative method, the paper-based device is a simple fabrication process. Just that the microfluidic characteristic easily diffuse into the channel and it can be interact with the ions and can be useful for the design. So these are the some of the schematic diagram already in the published article. So see here, this is the fabrication process. First the inlet, then the separator layer, and then they are creating a different pattern on the each paper substrate. And also for example inlet, when adding the water droplet containing a desired analyte, then what will happen in then outlet it will diffuse after some time. So in between, what will happen? This is the pressed region. So when adding the droplet, it will pass into here and diffuse here. Here already we have colored dye. When analyte molecule, if we exist, for example, we want this cysteamine. Here they are particular colored compound. When cysteamine is interactive with this colored compound, it can be produced here some new color. So based on the color change, we can easily detect the analyte molecule, and also the intensity of color can be easily correlated to the how much concentrations are exist in the our passing solution. So this is the applied they are calculating the electrode fabricating property, and these are the how the sensor can be fabricating with a different conversion of vas coating and the channel. So this is act as a channel. Here the black color like is a wax curve line. The interior white color is a paper based substance, so it can be diffused here. So when adding a liquid, it can be easily diffused into the wax. So this does not uh, the adding droplet liquid does not pass beyond this wax coating. So this is the beauty of this paper based microwave. This professor has performed extensive research on this topic. So see here. So another paper things. Here also the paper packing tape, simply they fabricated that because this fabricating device does not require any specific instrument. Simply we can cut a simple fabrication setup is enough for fabricating the microfiber devices. For example, here packing tape, simply used a packing tab, then they have attached a paper and then double side tape. So only here the for fabricating this micro pad technique we need only packing tape, paper and a double side tape. So just pre-pattern the paper and assemble this device. Then here this transparency, then when adding the liquid what will happen, it will diffuse into a different part. So here they can use here for the detection of different metal ions. For example, here they can add nickel, copper, iron. So to detect the different metal ion, they have fabricated this paper-based analytical device. So here our sample, our real samples, our desired sample are containing the solution containing different metal ion. When adding here, suppose if the solution adding only nickel, the solution, our investigated solution containing only nickel, if adding here, what will happen? It will diffuse into the all direction. So in order to identify the nickel, already they have pre-modified this part. Suppose if we want to identify copper, only copper, they pre-modified this region. If we want to identify only the iron, they will pre-modify some organic compound, or what will happen? For example, if nickel, if we only presence in nickel, it will transfer here. So if it is some organic molecule or complex molecule, when interact with the nickel, completely color will change. So based on the color change, we can say if it is nickel. For example, here the same nickel, if we penetrate here, the color does not change because this modification different, this modification different. This modification only color will appear when interact with the iron Fe. Similarly, this spot only color will appear when interact with the copper. This spot only interact with the nickel. So if the solution containing three metal, then only all the three spot will be color change. If it is only one metal, for example, if it is copper, in our mixed solution only copper and other metal, so what will happen? Only the copper part can be color change, remaining other part does not color change. So this is the advantage of paper-based device. Simple fabricating. For working space also we need a small computer table size is enough for fabricating device and measurement device. So currently this device is highly motivated to fabricate a different type of sensors. This also we can use for the different type of detection of biomolecule. Even enzymatic reaction also we can do, or nucleic acid hybridizations also we can do using these paper-based microfluidic devices. So this is another approach. There are different things we are developing. It has been developed by the various researchers using this paper-based technology. For example, here they have used antigen antibody interaction. Similarly, the paper can be modified with some particular antigen antibody to study the immunoreaction, and also this is a flat surface measuring cell. Based on this flat surface measuring cell, we can, when interact with some analyte molecule, changing the signal we can observe. So this output we can monitor based on optical and as well as electrical. So based on our requirement, we can change the output. So especially here that colorimetric output is more popular in the paper-based technique because it produces a simple color when modifying with the paper substrate and interact with some analyte molecule, it produces a different color based on color change. Similarly, the electrochemical approach, electrochemical technique also we can use this paper-based technique to interact the some molecule. So here the final conclusion. So in this lecture series we can we discussed about in detail importance of biosensor and how the biosensor has been work, and what are the current challenges in the biosensor, like is self-powered and flexible, wearable, continuous monitoring. There are different challenges are occurred in presence of in the current developing biosensor. So in this direction we discussed how these challenges can be overcome by the new innovative biosensor based on the nano-generator devices. So the nano-generator devices can be make as a self-powered biosensor, and also flexible wearable sensor also can be applied. So currently there are different in-depth research are ongoing. So further, this fabricated nanogenerator device can only not only apply for the medical, it can be applied for the environmental and food monitoring area. And also the paper-based device, simple and low-cost approach will be attractive in future decade for the visual detection and determination of several analytes in many areas. So currently this topic is also very important, and it can be give the perfect solution for the future biosensor to solving the current problem. By using this technology, it can be solve our problem. So hope this lecture series is made very useful for the understanding the biosensor and the future direction and current challenges. So in the following lecture series, we will see in-depth study about how the electrode fabricate and what are the basic principles will involve in the biosensor fabrication. Thank you.